8th grade. This is a video on easy acceleration problems. So these are just kind of three basic acceleration problems that I just wanted to show you in case you forgot from class or you didn't have your notes or you pulled an 8th grade move. Here are three examples of the basic types of solutions. There are some other ones that we'll talk about, but I also want you to have to, work through those on your own a little bit as well. So remember, for each of these acceleration problems, we're going to set it up the same way. We're going to have A, V, V, T, and T, 2, 1, 2, and 1. I know, I'm a pain. We're solving for acceleration, so we're going to circle that one. It is moving 50 miles an hour, speeds up to 100 miles an hour. So the second velocity, the one that it speeds up to, is 100 meters per hour. The starting velocity is 50 meters per hour. And it takes 10 seconds. So the second time will be 10 seconds. That's how much time has gone by. And our starting time is just 0. So we're going to set this problem up. A equals, here we'll put the equation over here, V2 minus V1 divided by T2 minus T1. So A equals 100 minus 50 meters per hour over 10 minus 0 seconds. So that'll give us 50 meters per hour divided by 10 seconds equals 5 meters per hour per second. 5 meters per hour per second. Now what this actually means here, how do you have 2 units for time? This means that every second you're moving 5 meters an hour faster. So after 2 seconds, you're now moving at a rate of 10 meters per hour. Another second goes by and you're moving at 15. So it just shows that every second you're getting a little bit faster. So this is a speeding up problem. The numbering got messed up here, but this question, the second number one, a car that is moving 200 meters per hour slows down to 20 meters per hour in 20 seconds. Find the acceleration. So again, we're solving for A, V, V, T, and T. So it is moving 200 meters per hour and it slows down to 20 meters per hour. So the second velocity is actually 20. Because it starts out moving 200 meters per hour, but it slows down. Its second velocity is 20. So that'll be 200. And it takes a total of 20 seconds. Its starting time was 0 seconds. So we will set that problem up the same way as before. 20 minus 200 meters per hour over 20 minus 0 seconds. So we'll have negative 180 meters per hour divided by 20 seconds. And that equals, I don't need a calculator, that equals negative 9 meters per hour per second. So what is up with that negative sign? That negative sign means that we are slowing down. With acceleration, the only time that you will have a negative sign is if you slow down. Right? If you are going from 200 meters per hour down to 20, you are not doing positive acceleration. Positive acceleration would be speeding up. Instead, you are doing negative acceleration. You are getting slower every second. How much slower every second? 9 meters per hour slower. So that's why we've got that negative sign. A car accelerates at 20 meters per second. Just FYI, another way of writing that would be 20 meters per second squared for 10 seconds. How far does the car travel? So we know that the equation for that is D equals 1/2 AT squared. So we need a little bit different setup here. We'll have D, A, and T. So time is going to be 10 seconds. Acceleration is 20 meters per second, and distance is what we are finding. So D will equal 1/2 times 20 meters per second squared times 10 seconds, all of that squared. So we'll get d equals 1/2 times 20 meters per second squared times 100 seconds squared. Look at this. Seconds cancel out. Seconds cancel out. We now have 1/2 times 20 times 100. So that'll be 1/2 times 20 is 10. 10 times 100 is 1,000. And this is the only unit left, 1,000 meters. So any of these questions can also be reorganized to solve for something else, right? This question here in number 1, rather than solving for the acceleration, it could give you the acceleration and you have to solve for time, right? If it said the acceleration was 5 meters per hour per second and it gave you the starting and the ending velocities, but it didn't give you the time, you could solve for it. You would just have t on the bottom and you would solve, just like when we were doing s equals d over t, you would solve for time. You could also do the same thing for velocity, right? That gets a little bit more complicated, but if you have a and you have the t and you've got one of the two velocities, you can solve for that second velocity. Not a problem, just reorganizing the equation. Same thing goes for over here. We could actually solve for t. If we were given d and we were given a, we can solve for t. We would just have to take the square root of it after we reorganize things. That gets a little bit more complicated. We'll see that in some questions coming up. But just if you stick by your math rules that you're learning in class, you'll be all set. Right? If you follow PEMDAS and you multiply by the denominator to both sides, all that kind of stuff, you will be all set if you're trying to solve for t or for, if you're solving for t over here or v or whatever. Just follow mathematical rules and you'll be able to solve these equations. Some of these questions that you'll see on the homework will get a little bit more challenging. They'll be like that, or they'll ask you to solve for how far they've gone, or for after a certain amount of time how fast they're going. That's solving for velocity. You can do it. Just follow the math rules and set everything up like this, and it'll be a lot easier. Please shoot me an email if you get confused.